Hello everybody. In this tutorial, I'm going to introduce how you can create a topology by MiniNet, and also you will learn some very basic operation for the RYU controller. Okay, so let's begin. As we know, MiniNet is a very powerful emulator for internet, so you don't need so much hardware and just one computer. You can create a type of topology that you need, and also we can use the different type of controller, which could be the POX. It's a default controller, and also the controller of RYU, and which we will test it today. So right now I'm gonna start a terminal, and from this terminal, and I will start a topology for a network, and we type sudo mn and topo. That means we're gonna create our custom topology. So how are we gonna create? We're gonna have like a one switch with the three hosts, and they're connected to each other, and with the MAC address of a in default address, and we need a switch, and the switch we're gonna use is OVSK, which is open flow, and later on the controller, which is also very important, where you're gonna use the remote controller, which is RYU. So, and then we're gonna type X. The X means we will use the terminal of each host and the switch, and in the mininet we call it the X term. So, and basically it's running. Okay, so now we have a like a mininet CLI, starting CLI client. So we have the controller right here, and this is host number one, host number two, host number one, two, three, and also there's a one switch. So actually today everything we're doing is based on the RYU book. So guys, let me show you what is it. RYU book. Yeah, it's here. So, and it's totally free. You can download it, and from here, from the index, we can see we're using the switching hub. So I'm using the switching hub controller, and you will see more detailed information from this chapter. Okay, so now I'm gonna do from the switch. I'm gonna show you some very basic command line to get the information. As show. So basically, you will see our controller, the address of controller. But right now, there's no such address. There's no controller so far, and this is the port. So there's like a one, two, three, four. So the port actually connected to the each host. So if we go there and type if config, and you will see the address. So right now, if we type the links, if we type the links, basically you will see how they connect to each other based on the certain port of their on certain interface of their own. So you can see that's the name of the interface. So they connect, no problem. Okay, and then the next we will do the OVS dpctl show. And this command line, we're acting for the dumping the flow. We're Yeah, it's not dumping flow. It's to check the port. So from the port one, port two, port three. So you will see the both command line is to show the detailed information about the port and also the interface connection. And next, we will set the version of our switch, which is OpenFlow 1.3. Let's set this protocol. We check it. OBS, VSCTL, set bridge as one protocols OpenFlow. Okay, it's working. Now we set the protocol of the OpenFlow. And later on, we're gonna see the most important function in the switch, which is the dump flow. So OVS, OFCTL. So right here is most important. You always need to remember, since we set the protocol into OpenFlow 1.3, so we need to specify the version of the OpenFlow. OpenFlow 13 dump flows S1. Yeah, it's working, but right now there's no flow table because we haven't pinned anything yet. So now we're gonna turn to our desktop and create a new terminal. And from this terminal, we're gonna create our, we're gonna turn on our controller, which is a simple switch pi. Yeah. Right now we have our simple switch, which is running. Uh, I think I forgot about one more thing. Sorry about this. I'm gonna kill the controller. Sudo user a. Okay, so from here I need to add the verbose. What is a verbose? Verbose means we can see the detail how we can run this switch. Let's go. Yep. So in this command line, it seems like they turn on a lot of things. And right here, I wanted to explain why it shows connected to socket, and you know, or probably you know socket about the Python software, Python web. So there is an event which is a hello. It's supposed to be hello something or whatever is the simplest word. So it's an event. So the event have been sent to confirm the, yeah, it shows the controller is connecting successfully. So, by the way of sending an event, and the event is important because it's like a message to show that it's a message to do the shake hand between the whole networking and the controller. So, based on this RYU, so actually we can see simple switch, simple switch 13. Yes, let's turn it on. Okay, so I'm not gonna talk about a lot of detail, but I will show you why the code is working like that. Okay, so basically you will see there's a declarator, and declarator means once there's a something happen and you have to automatically run the certain method. And right here there's a event of a switch features. So the config dispatcher means it's in a certain state. It is in a certain it's in a normal state. So basically, there's a packet in handler. So the packet in handler means there's an event. Event hello event get inside of the controller, and the controller receive the packet in, and the packet in gotta go into the host system and try to build the data path, which is the the configuration of the switch. So, and the address will save into the MAC to port dictionary, and which is a data type of a Python 2.7. So that is a very brief and direct explanation. I will show you more later on, but let's close it and focus on our experiment. So in this experiment, uh, we already turned this controller on. So right now we can do something about our networking and try to query more information from it. So remember, there's a command line to dump flow, and we dump nothing because there's no controller even. So right now, if we do the dump flow command line again, so we will see actually there is some packets getting inside or flow inside of it. Why? Because of the event of a hello get inside. So that is basically what it is, but it doesn't show the flow. Doesn't show the flow table between any switch. Well, between any hosts. We need to ping it, and after ping it, they will write the data path into the switch, and we can dump flow and get more result. And right now, we're about to do that. Okay, so TCP dump. Okay, so what does it mean? That means it opened in a verbosing way. It will show a lot of detail about the host one, and it will listen to this port, the H1, and it will listen to this port, and also will capture every changing of the state about this H1. So it's a good listener. So we set up another listener. Okay, done. Okay, perfect. After setting it, and we can start to ping H1 from H1 to H2. Remember, we will set the counter equals to 1, so we will only do one packet sending and receiving. H2, yeah, so that is a packet sent, and you will see how it changed. So the basic process is H1 doesn't know where is the port and MAC address of H2. So the H1 will send this packet to the switch, and the switch doesn't know where is H2 later. So the switch will do the flooding, and after do the flooding, and they know where H2 it is, and H2 need to tell back to H1 that I am here. So after the H2 tell back turn back to H1, and H1 started to send the message, and from H1 to H2 again. And after the H2 receive it, H2 need to tell the H1 uh, that H2 receive it. So basically, this is a 1, 2, 3, 4 procedure in all single data packet sending and receiving. So we send a one packet, then we need to go 4 procedures, and it is all about the and ARP and ARP and echo reply protocol, if not mistake. Yeah, echo reply, echo request, and tell, and yeah, basically that's it. But since H3 doesn't need to send back, so the only packet, the only data or the H3 receive is the flooding information. Just as I mentioned, the first stage, the flooding information. Okay, so the last step, we're gonna start to dump our dumped our table from S1, and you will see they update the table into several packets. Okay, and more detailed information actually you can check through the mininet, the RYU document 1.0, as I told you before. So basically, that's the operational part of the simple switch. I hope you like it. Thank you.